Welcome guys, welcome to IMED Engineering. In today's class we are going to be talking about what is part and point function, differences between point and part function. Please, if you are new to this channel, do ensure to hit that subscribe button. This is going to make a huge difference, and on the notification bell. In case I release new video, you will be the first to see it. Without further ado, let's jump right into the video. Part function is a function whose value depends on the path followed by the thermodynamic process, irrespective of the initial and final state of the process. Example of part function is work. So, part function depends on the path followed by the thermodynamic process. It doesn't depend on the state. Just like in the example given above, in the pressure volume diagram given above, we can see that for the same initial and final state of the thermodynamic process, the work done in all the three processes, process A, process B, and process C, are different. For process A, work done is B2 A1 A. For process B, work done is B2 B1 A. Likewise, for process C, work done is B2 C1 A. We can see that for the same initial and final state, the work done in all the three processes are different. What does that mean? That means that part function depends on the path followed to reach. It depends on the path followed irrespective of the initial and final state. You can see that for process A, work done is from B2 to A1A is different from work done in process B, which is B2 B1A. It's also different from the process followed in C, which is B2 C1A. So path function depends on only the path followed by the thermodynamic process, irrespective of the initial and final state of the process. Another example of path function is heat. Heat is another example of path function. Heat also depends on the path followed by the thermodynamic process, irrespective of the initial and final state. It is also a path function. Moving down to point function. What is point function? Point function is also known as state function. It is a function whose value depends on the final and initial state of the thermodynamic process, irrespective of the path followed. It doesn't depend on the path. It depends on the state, irrespective of the path followed by the process. Examples are density, enthalpy, internal energy, entropy, etc. Just like in the pressure volume diagram here, you can see that P1 pressure, initial pressure, you can see that initial pressure and final volume. We have it only depends on the point. You can see for this point, this is only where point function is insignificant. For pressure, this is the final pressure, and this is also the final volume. So it depends only on the state of the thermodynamic process. It doesn't depend on the process. you can see it doesn't depend on the process, only depend on the state, only depend on the final and initial state. This is the final pressure, and this is also the final volume. So it depends, final pressure and final volume. We have a point function 2 here. We also have another state 1 here. So that means it does not depend on the path followed, it depends only on the state. So pressure and volume are all examples of point function. Note that all point function is a property of the system, or we say all the properties of the system are point function, while a path function is not a property of the system. Why is a path function not a property of the system? Because path function depend on the process irrespective of the initial and final state, while point function depends on the state. The values depend on the state to reach, depend on the state. That's why it is a point function. Now coming down to point function and differences between point function and path function. Number 1, it is an inexact or perfect differential. It is an inexact or perfect differential. Why is point function an inexact or perfect differential? Because for an indefinite integral, for a differential, it only has end state. It only has end state. While path function, it is an inexact or imperfect differential. Why? Because it depends on the process followed. So for an indefinite integral who only has end state, path function is an imperfect differential. While for point function, which has an end state, therefore it has a perfect differential. Number 2, it is property of the system. Yes, point function is a property of the system because it depends on the state. It depends on the state. While path function, it is not the property of the system. Why? Because it depends on the process irrespective of the initial and final state. It depends on the path followed by the thermodynamic process irrespective of the initial and final state. Number 3, its values are based on the state of the system. Its values are based on how that particular thermodynamic state is achieved. Therefore, it only depends on the process in which that particular thermodynamic state is achieved. Only the initial and final state of the process are sufficient. Only the initial and final state are sufficient. We need no exact path followed by the process. We need to know the exact path followed. If you don't know the exact path followed, it's not a path function. Its examples are density, enthalpy, internal energy, entropy, etc. While examples of path function are heat and work. They are examples of path function because they depend on the path followed by the thermodynamic process irrespective of the initial and final state of the process. Guys, this will be the end of our class for today. Hope to see you in the next video. Goodbye and thank you for now.